examples number 3 and 4 are working backward. So this is example number 3, and I'll do 4 in the same video here because they're going to be fairly quick. When you look at an expression like this, you don't know what pi over 12 is necessarily off the top of your head what the sine value is, or the cosine is 7 pi over 12. But what we can recognize here is that this is obviously the formula for the difference of two angles as far as sine is concerned. So we have sine of alpha minus beta is equal to the sine of alpha cosine beta minus cosine alpha sine beta. If you look, that means that sine of alpha minus beta here, alpha, it looks like, is pi over 12. And beta then is 7 pi over 12. So this says that alpha should be pi over 12, beta should be 7 pi over 12. So what we're really trying to find when we do this guy out right here, what we've really got is the sine of pi over 12 minus 7 pi over 12, which is equal to the sine of negative 6 pi over 12, which is equal to the sine of negative pi over 2, which is equal to the negative sine at pi over 2, and the sine value at pi over 2, or 90 degrees, is 1, so this should be a value of negative 1. So if you plug this guy, this whole big thing up in the top in your calculator, you should get negative 1 out. Number 4 is the same procedure. So for there, we've got the cosine of 70 degrees times the cosine of 20 degrees minus the sine of 70 sine 20. So I've got two cosines on the left. When I say left, the kind of the left side of that negative, and then two sines on the right. So this is going to be a cosine formula. And we know that the cosine of alpha plus beta is equal to the cosine of alpha cosine beta minus sine alpha sine beta. So that must imply, putting these two things together, that my alpha is 20 degrees and my beta is 70 degrees, and I'm using the addition. So this guy right here is equal to the cosine of 70 plus 20, which is the cosine of 90 degrees, which is 0. So for number 3, your answer is negative 1. For number 4, your answer is 0.